Hello everyone. Today we want to discuss banked angle in physics. So as you know, banked angle is an angle that helps a car to turn safely on a track. So imagine there is a racetrack. So it's something like this. And so there is a car on this track, which the car tends to turn on this track. So then we have to discuss several types of force applied on this car. So as you know, there is a normal force which is always perpendicular to the surface. So then I have Fn, which is perpendicular to the surface. And then, so I have gravitational force, which is always downward. So this is mg. So the other force we have is like static friction. Why static friction while the car is moving? Because so the car is moving on this track, which is a curved track, but if there is no friction, so then the car tends to the slides up is like this. If there is no any friction, so then there is static friction between the tires of the car and then the surface. So then static friction is downward to the ramp. And then why it going like this way and then not this way? Because if you don't have this friction, then the car will be sliding up. So then I have these forces here, and then so because we have a curved track, then so always there is centripetal force, which is that is a net force. So then it means I have to calculate all forces horizontally, or like all forces along the radius for having the centripetal force. So then I have one force that is centripetal force, that is a net force. Okay, but to calculate this centripetal force, we have to calculate every single effect of every single force applied on this car. Okay, so what we're looking for in this case, so we're looking for the safest speed for this car to turn on this track. Okay, so I have to take, because I have like 2D system, so then I have something vertical like this force, and then I have some force diagonal, which is like this force. And then so I have to break them down, break all forces down into like X and Y components. So then I have to take this as X-axis, and then I have to take this as Y-axis. Okay, so once I look at that, like once I look at those two axes, so I can see like I don't have any issues with this mg because it's along with the y-axis, so then no issues. But I have to break down these two forces, Fn and then Fs, because those are diagonal forces, and then those are not like neither on x nor on y. So then I have to break them down to make all calculations simpler. Okay, so if I have this angle is theta, like any number could be this angle. So then this angle is gonna be theta, and then also this angle is theta. If you don't know how, you can ask me in the comments, so then I'm gonna explain in another session. Okay, so then this is theta. So then if I want to break this down, so then I'll have Fn. So I call this Fn cosine theta. Why? Because this is the length attached to this angle. And then also, so I have Fn sine theta. So then I'm using equivalent vectors to Fn. So then I don't need this force anymore, because I'm using these two equivalent vectors. And also for Fs, so I'm gonna use another color. So then for Fs, so I have this angle here. So then if I want to break this down, then so I'm gonna have this much and then this much. So this is gonna be Fs sine theta. Why? Because this is the opposite length. However, this one, so it's gonna be Fs cosine theta. Why? Because this length, this, attached to this angle. So then to this angle. Okay, then I don't need this Fs anymore, because I'm using equivalent vectors, which are Fs sine theta and Fs cosine theta. Okay, now, so I'm looking for, like I have to calculate safest speed, but how? So Fc, which is centripetal force, is going to be MAC, which is centripetal acceleration, and then equals AC is going to be V squared over R. So then I'm looking for this speed, because this speed will give you that safest speed. So in such case, in such questions, usually the mass, this mass won't be given. So then this won't be given. But then how can I solve that? So I have two axis system, right? So then I have to solve every single axis individually. So then I'm gonna start with y-axis. So then y-axis. Why I have to start from y-axis? Because I have to calculate Fn component to calculate a static friction. And then so we know Fs is going to be mu s times Fn. So then I have to calculate Fn to calculate Fs. So then I start from y-axis. So then I have to look at the y-axis. So conventionally, we got up as positive and then right as positive. So then if I look at the graph, I have Fn cosine theta going up like this. So then I have Fn cosine theta, and then I have Fs sine theta. So this is positive, but then Fs sine theta is going to be negative, and also I have another force along with y-axis, which is mg. So then minus mg. Okay, so these are net force along with y-axis. And I know the car is not jumping up, right, on the ramp. So then AY is going to be 0. So then if AY is 0, like F, which is equal to MA, then Fy is going to be 0. So like sigma Fy. So it means the sum of all forces along y-axis. Okay, so then sigma Fy is going to be 0. So then for y-axis, these are 0. But that means the sum of all forces, not individual force. Okay, so then so I'm looking for Fn, so I have to isolate this equation, like I have to solve this equation for Fn to calculate Fn, and then to plug into this formula to calculate Fs. So I'm gonna do it here. So then Fn cosine theta minus Fs, we said it is mu s Fn, and this is Fs multiplied by sine theta minus mg equals to 0. So then Fn, so I can factor out Fn here, and then that is cosine theta minus mu s sine theta minus mg equals to 0. So then Fn is gonna be mg divided by cosine theta minus mu s sine theta. So then this is gonna be Fn. So then I have to do the same for x-axis. So then for x-axis, so I have to consider all forces horizontally, like all forces along the x-axis. So then I have two forces, right? So one is Fs cosine theta, and then the other one is Fn sine theta. So then I have negative Fs cosine theta minus Fn sine theta, right? And then so how much would be that? So then this is exactly equal to that centripetal acceleration. So then this is going to be equal to mv square over r. We got it from this point, right? So then here it is. Then minus f. Okay, so then we have minus fs cosine theta minus fn sine theta equals to mv square over r. So then fs is going to be mu s. So then I have minus mu s times Fn, which is mg cosine theta minus mu s sine theta, then multiplied by cosine theta. This is Fs, right? So then this is Fs, then this is cosine theta, and then minus Fn, which is mg divided by cosine theta minus mu s sine theta multiplied by sine theta, which is this is Fn, and then equals to mv square over r. Now if I factor out m, so then so I can do it here. So if I factor out m, then I have negative mu s cosine theta divided by cosine theta minus mu s sine theta, and then minus g times sine theta divided by cosine theta minus mu s sine theta equals to mv square over r. And then as you can see, I can cancel out this, like these, the mass, and then so I have g, I have like sine and cosine of the angle. I can easily calculate with a calculator. So then I have every single number here, and then I have like radius, and then I have mu s. So then all numbers here are given, then so you can easily calculate the safest speed here. So if you have any question on this, please feel free to ask. You can put any comments on any topic you like to learn more about. So I'm gonna explain those things in the next session. I hope you liked this session. Thanks for watching, and then see you in the next class.